Okay, next up is Hart from UMA or UMA. Hey Hart, how are you? Yep. Turn on your microphone. There you
Yeah, I'm off mute. Can you guys hear me okay?
Yeah,
How's my
yeah.
internet? I hope my internet's okay.
Are you in New York City?
I am not currently in New York City. I'm actually in Canada right
Okay.
now.
All right, so
So,
might be some connectivity issues. We're finding that people that are outside the U.S. there is some connectivity issues. Hopefully, there isn't. You're doing well so far. Is UMA the right pronunciation, or is it UMA?
you know, I really should have a firmer view. We go both ways. It stands for Universal Market Access. I like
Okay.
that. But yeah, go with whatever you like.
I mean, because when I say UMA, I just think of Uma Thurman, and I go off in a different direction. Uh,
Well, we kind of like that
I don't
meme,
think,
right? Like we actually made as a joke, we made Uma thermoses that were kind of based off Uma Thurman. So our
oh, really?
swag were, yeah,
I
they're
would. I would
pretty
like
good
to get one.
swag.
I like to get one. That's fantastic. It's a great idea. Okay, so let's get to your talk. If you've got a presentation, there's a share icon on the bottom with an up arrow. Please click on that. Tell us about yourself. What were you before UMA or UMA, and what you're doing with UMA, and then onto your topic, which is building options, right? Using options on UMA. So stage is yours, sir.
Yeah, well, thank you. So first of all, guys, I've got a special treat, which is my hand-drawn presentation that I
That's
made with my iPad.
I love it. that's that's like graffiti.
I have a feeling I'm going to be the only one with this type of presentation in your series, and we'll see how it goes.
It's
But
probably going to be the most read and looked at. It's great.
so, for a little bit of background, I'm the co-founder of UMA or UMA. It stands for Universal Market Access. Uh, Previously, I come from a technical background. I'm a computer science guy, but that worked in finance in New York for 8 years at Goldman Sachs trading bonds, which gave me a bunch of finance knowledge. And then I had a fintech business that I started in 2013 and was acquired in 2017 when I should have been in crypto the whole time. So our whole vision here is really looking at how to use blockchains to program incentive structures to allow risk to be universally transferable. And we've really been on this DeFi train since pretty early on. And in my opinion, like Ethereum and crypto really is about finance and about decentralizing it. So whereas today, the financial products and services that are offered in traditional finance, they're all gated by your local jurisdiction. They're gated by where you live. And it's really a matter because they're enforced by legal recourse. So the financial products that are offered in the US are different than what's offered in Canada, than the UK, and certainly than different what's offered in the developing world. Because the enforcement mechanism is all localized or tied um, to their local legal jurisdiction. And our whole vision here is to use the blockchain plus economic incentives to design systems, protocols that allow financial risk and financial products to be accessible globally to anyone with digital money and an internet connection. So, all right. So for this presentation I want to go through a little bit about how we can build options with the UMA protocol. And our protocol today, what we really do is we help developers build synthetic assets or synthetic tokens. And we look at ourselves as a developer infrastructure, as a tool set really for developers to build their own products. So we like to think of ourselves as like a Stripe, like a set of tools that let other developers be successful. And our design for synthetic tokens is tied to a very specific Oracle design that we call a priceless framework. We call it an optimistic Oracle design, where we attempt to minimize Oracle calls, which allows us to create a very flexible system where we can effectively query for anything and do it in a secure way. So I'm not going to go into too much of the details around the Oracle design, but I want to talk more today about what we can do with this. So what are synthetic tokens here? The idea is that you take an asset and you define some payout function, and boom, you create this synthetic, this other token that is a derivative of the original asset or payout. And in our version, the way our synthetics work is we can take any ERC20 asset, anything that's a type of collateral on the Ethereum blockchain, and we can define a payout function that's basically any type of math plus price, anything we can observe in the world. And I'm going to give some examples of what those could be. And there's this sort of magic formula of any ERC20 asset plus any payout function allows us to create a synthetic asset that really can track anything. And the strength of our design is this optimistic oracle really does give us a lot of flexibility in defining what these payout functions are and how they work. So let's give an example of like what this works or how this would work for something that people are generally familiar with, which is this this maker DAI, like maker's DAI, the kind of the first thing here, first real synthetic that hit the DeFi space and hit Ethereum. I'm really, to be specific here, I'm simplifying this, and I'm talking about the original version of Maker's system, where it was a single collateral DAI, or what they called Psi for a bit there, where the idea is I can take an asset like Ethereum, and I can use it to define a synthetic token that's worth $1 of that asset at some payout, and that thing is DAI. It's pretty cool. I created a stablecoin by doing this process, this transformation process. It's almost alchemy. And of course, you can also think about the other side of this. The person that's created this synthetic token and then sold it, they have the opposite position of the person owning this token. And in the case of Maker's DAI, the person that created this token and sold it, they are levered long Ethereum. They're getting levered exposure to Ethereum. So we can take Maker's concept here, or this, again, this alchemy process of transforming an asset plus a payout function to a synthetic token. And we've generalized it. Our synthetic token design can really be thought of as this generalized version of this alchemy, of this transformation process. And we put together some of the first products we launched using this system are what we call yield dollar products. These are like zero coupon bonds, where we can take an ERC20 asset like wrapped Ethereum or RenBTC, and we can define a payout function that at some expiry date, the synthetic token will be worth $1 of that underlying asset. And boom, we've created this yield dollar, or this sort of stable coin, this zero coupon bond that will be worth $1 of the underlying asset at expiry. And it's pretty wild. This simple concept is pretty wild in terms of what we can create in just this yield dollar domain. We can go and we can say, okay, hey, let's create a fixed term loan for Bitcoin. We call those like yield dollars backed by RenBTC. And this is live and something that exists today. We can do the same thing for Ethereum. And this looks a lot like single collateral DAI, but with a fixed lending rate. More recently, we're working with the Badger DAO team to create B clause and S clause. And these are, in my mind, really interesting examples of other types of products that can be created using, again, this type of payout. And here with Badger, what we're doing is we're realizing the Badger ecosystem has a lot of these ERC20 assets that are valuable. These are the Badger Vault tokens. These are people that have deposited assets into Badger Vaults, and they have this receipt that is this Badger Vault token. But what we can do is we can say, hey, that thing is a useful piece of collateral. We can use it and add a payout function to create a synthetic asset tied to the value of that Badger Vault token. And in this case, if we say, hey, we're going to create a synthetic asset that at expiry is worth $1 of that Badger Vault token, we've created a zero coupon bond backed by Badger Vault tokens, which means we can let the token holders get leverage on their positions. They can actually use this to mint tokens and sell them. and get leverage on their Badger Gold positions. And other people that want to earn yield can go and buy these Badger dollars and actually accrete value. So it sort of plays into the whole money Legos meme, where we can continue to transform assets from one ERC20 into something else in a way to make them useful. So another idea that we came up with a couple weeks ago is this concept of KPI options. And by KPI, I mean key performance indicator, or basically some metric. And the observation here is, well, we can take the same synthetic token formulation and we can make the asset be a project token, like, for example, say our own UMA token. And we can define a payout of that token based on some KPI, based on some metric or some goal that the protocol is attempting to achieve. And then out comes a KPI option, this new thing that I don't think has actually existed before, but this idea of a token to mint a bunch of these TVL options. These options will pay out a variable amount of UMA tokens based on the TVL that's observed at an expiry date. So right now, at a floor of 100 million, circumstances, instead of giving people just our token, we can give users or community members this option where if the protocol succeeds in hitting its KPI, the token holder, the option holder, actually succeeds too. The community gets to participate in the option success or the success of the project. So I think this is like a really interesting idea for aligning incentive structures and being able to align the interests of the community with the key goals or metrics that a project is trying to achieve. And the design space here is pretty big. So we started, or we're creating a version of this that's based on TVL, on total value locked, for our own project. But depending on what you're trying to achieve, we think there's lots of interesting use cases. An automated market maker, say a Uniswap, SushiSwap, that type of thing, could instead choose a KPI based on the total volume traded in their exchange, which is maybe a better metric for them to target. Other possibly consumer-facing protocols could choose a user-based number as their KPI. So the protocol or the option payout could be tied to the number of users, their daily actives, their monthly actives, something like that. The broader point here is that the design space for what we can define, what we can use as the payout function here is just really, really vast. So, like, to keep going here, we've kept realizing that we can do more and more with this concept. It recently dawned on us, perhaps stupidly, because we maybe should have thought about this a while ago, but we can create call options on any ERC20 asset. These are a cash settled call option. So you get money at expiry if you're in the money. You don't have to pay to exercise the strike. But the simple idea here is that we can take an ERC20 asset, we can define a payout function, which is how much of that asset you would get at expiry if you are above the strike, and boom, we've created a call option. So let me actually walk through the math behind this for, say, what I think we're going to do. And this made it, the slide looks a little uglier, a little messier. My handwriting's not the best here, but say we wanted to make a $40 strike on the UMA token. right now our token's trading at around a price of around $20. And so if at expiry, the price of UMA is below 40, the option token holder gets nothing. Fine. Let's say the price is at $60. Well, then according to this math, what we do is it's this option holder is $20 in the money, which when the UMA token is worth $60 means at $20 is a third of an UMA token. So that option would be redeemable for a third of an UMA token. If the price was at $80, that means the token holder is $40 in the money, which $40 if at a price of $80 per UMA is half an UMA token. So that option would be redeemable for half an UMA token, etc. What's really cool about this concept, well, there's a couple things. So the buyer of the call option gets, of course, levered upside in the price of the protocol. The seller of this call option, the person that mints it, is effectively minting a covered call. So covered call is a bit of a finance nerd term, but basically if I own an asset like the UMA and I sell a call 1-for-1 against that, it means I'm selling some upside in the potential price appreciation of that asset for some premium. And it's a way for me to generate yield on my assets. So that's pretty cool. We've created another structure using the synthetic token design where the option holder owns a call option, the option creator writes a covered call, and there's a marketplace to trade these, namely an AMM. What's even more wild is that we can collateralize this thing. This thing is all collateralized with our project token. And so our treasury can actually go and finance a fairly liquid market to actually make these things be tradable early on. And I'm going to actually kind of wrap this up pretty quick just to take questions and just to sort of talk through some of this finance nerd stuff. But to sort of summarize this, like, what have we actually demonstrated here? We've shown that these UMA synthetic tokens are this powerful primitive to transform an ERC20 asset into something else. And then we've shown that this design space for what you can do with this primitive, what you can do with this alchemy is actually really vast. And we're just getting started. We only recently stumbled upon the idea that, holy shit, we can use this to build call options. We can use this to build these KPI options, this new thing we invented. We can create zero coupon bonds. And that's all on top of what we thought were the original use cases of creating a token to track the price of gold or some other real world asset. And so we're getting quite excited about what this primitive could enable and how we can use this, this transformation process to create more and unique ERC20 tokens for people to play with. Yeah.
Okay, lots of questions, and we've got a limited amount of time. So is this similar to an American? So I used to work at Lehman, and we were doing mortgage trading and fixed income trading, and did some options trading. And there was American style options, there's European style options, and there's all these Greeks and things like that. So which is this? The options that are created here, are they exercisable at any time? Can they be exercised at any time, or only at expiration?
These are European style. They're only
European style. Okay. Yeah. And then in terms of like the mathematical model, and in the options world, and Black-Scholes doesn't really hold up in the real world. But how are you modeling the pricing? How is that modeled? Is there time? Time decay? Is it theta there? All that. All the other Greeks are they applicable, or is this completely different? Is there a different model now for this?
All the modeling is the same, but our general strategy here is we're just going to seed a market for these and let the market decide what the value should be.
Got it.
So like as a preview, our intention kind of like to do is early next week is to seed a market of these for our own, call it $35 or $40 strike on the UMA token. Right. And We're going to set an initial price by creating these options and setting an initial price in an AMM pool. We'll set an initial price that is a guess. It's going to be a best guess at like where we think these should be. And then we'll see where the market prices this. So the most interesting thing here actually is like trying to then glean information from where the market puts these things.
Got it. So we have a couple of questions. One from Lewis: what is the main difference between UMA and synthetics? And what is UMA's edge? And that's the question.
Yeah, I think we're complementary approaches. So synthetics does a lot of really, really interesting things where every one of their synthetic assets is backed by a global collateral pool. And so you take like the SNX token collateralizes the global pool, and then everybody trades against that. And so that's like really fascinating concept for a bunch of reasons, because you're trading with this one global risk pool. But it has its downsides where that global risk pool is constrained. You can't just add any new asset to it, because if it breaks, the whole thing breaks. So our approach here is the fact that we are segregated pools. Each asset or each token is its own segregated pool of risk. And specifically, our approach to the Oracle problem gives us a lot of added flexibility. So we don't need an on-chain price feed for any of these options, any of these tokens to exist. The whole optimistic Oracle design that we have is that we only use an Oracle when there's a dispute about a liquidation or a settlement. And I could spend a lot more time getting into this optimistic framework, but the whole idea here is to minimize Oracle usage and instead have an economic game where actors are keeping each other in check, and only disputes need to actually go to an Oracle for resolution. And the advantage of this approach is that it just supports a long tail. It supports us actually creating synthetic assets that track anything versus being constrained to whatever is supported by an on-chain price feed.
Got it. Okay. We have another question. I think you may have already answered this, but I'm going to ask it anyway, in case you have something more to add. What is the advantage of using UMA options versus options created from an options protocol, I guess, like synthetics? They all seem to work in very similar ways. I think you already answered that, but anything else you want to add to that question?
No, I think I know Julian, he's asking, but like
he's messing with you?
It's a good question. I think I think all these option protocols are good and kind of cool and should all coexist. There are different approaches, like Hedgic is trying to let you price your own option based off of your own strike or expiry, which is a different model and interesting, but different. And then pricing that becomes difficult. The only thing we realized here is just this synthetic, like we're not an options protocol. We're just trying to create this infrastructure for synthetic tokens. And we realized that, holy shit, you can use this to create call options pretty easily. And I think the advantage here is like, well, if you have a lot of a project token like in your treasury, you can actually create a pretty deep and liquid call options market for your own token really easily using this infrastructure. And that's a kind of insight that we only recently came across, and we're like, holy shit, like that makes sense. A lot of these big projects should actually go and seed options markets on their own protocol because A, it's interesting, and it sort of provides some utility to their token holders. And B, like it allows people to sell calls on them and kind of locks up your token supply and just creates a deeper and more vibrant market for your own project token.
Right. Okay. We've got a lot more questions than we have time. And I've got a ton more. I'm kind of holding back. But this obviously this is all in a white paper, right? Your framework, your synthetic token framework. is all described in a paper, in a white paper on that website, I believe. Correct?
Yeah, and our docs, honestly, our docs are probably the simpler or more lightweight version.
Right.
There's also a couple Medium posts. If you're specifically interested in the KPI options idea or the call options idea, there's 2 Medium posts that have been put out in the last couple weeks that I encourage people to look at.
Okay, I'm going to ask one more question from Lewis. Any linear products like stocks in your future, or your main focus is just derivatives?
So just to be pedantic for a second, everything is synthetic, so it is a derivative product. But yeah, we started with linear products, right? There's something being created by the YAM finance team called UStonks, which is an index of the 10 most popular stocks on Robinhood. It doesn't have to have embedded optionality. Lots of linear things are very much our focus, or where we started.
Got it. Okay. That's all we have time for. Hart, thank you so much for your time. This is really interesting stuff. I love it when we see the inspiration of like, wow, we can do this, and you never thought about it, and wow, and it opens up potentially a whole new world, a new way of doing things. The unnecessary reliance of Oracle and mitigating that is very, very interesting. So I wish you guys success, and hopefully we'll have you back on some of the other stuff that we were doing down the road.
Thanks very much for having me. It's been great.
Great. Thank you so much. Take care.